Hi folks, we're going to take a look at number 6c on page 575. So here they're asking us to solve the equation f prime at x is equal to 0. So in other words, when the derivative is equal to 0 and with this given function. Okay, so first step is to find the derivative. Now I notice that they've given this to us as a product with this function to the -1, but it'll be much simpler to evaluate the derivative and then to simplify if we write it in quotient form. Okay, so I'm going to rewrite this as ln of x squared plus 1 all over x squared plus 1. Okay, the only time you should really be doing something like this is if you have, as an example, a reminder, if you have f at x equals, 8 over x squared plus 1, it doesn't make sense to use the quotient rule, but to rewrite this as 8 times x squared plus 1 to the -1, and then use the chain rule. But in a circumstance like this where you've got two functions, usually better to write it as a quotient. All right, so now that I have it in this form, I'm going to take the derivative. All right, so let's follow our formula. So we've got derivative of the numerator. So here we're going to have to take the, you have to use a chain rule. So derivative of ln u is 1 over u, so 1 over x squared plus 1, okay? And then times the derivative of u, so the inside here, derivative of x squared plus 1 is 2x, all right? So now that we found the derivative of the numerator, we multiply that by the denominator function, so x squared plus 1, okay? Then we subtract the numerator function, ln x squared plus 1, times the derivative of the denominator, which is just 2x. Okay, and all that is going to be over the square of the denominator. Okay, so now we see that there's a bunch of simplification we can do, and a really nice one here is that this x squared plus 1 in the denominator reduces with that one in the numerator. All right, when you're trying to simplify, the main trick that we looked for was to determine if there's any common factors, and I see here that there is a common factor of 2x in the numerator, so I will take out that common factor, and then what we're left with is, well, we're just left with 1 because we removed all the factors, and then here minus ln of x squared plus 1. Okay, and then of course all over x squared plus 1 squared. And we want to solve when this is equal to 0. Okay, so since it's a fraction equal to 0, we only need to determine where the numerator is equal to 0. So here we have either 2x is equal to 0, or this expression in the bracket is equal to 0. 1 minus ln x squared plus 1 can also be equal to 0. So this is nice and easy. X equals 0. Okay, however, when I look back at my original expression, why am I doing that? Because my original expression has a logarithm in it. And you always have to check that any answer you get satisfies the original equation. However, here, I'm not going to have any problem because when I stick in x equals 0, I have ln of 1, and that's defined. Okay, just remember to always check. So that one's okay. And in fact, when you take a look at it, any value of x will be fine, because remember what you need for a logarithm to be defined is for this input to be strictly greater than 0, and x squared plus 1 is always greater than 0. So I don't need to worry, but it's always a good idea to check anytime you have something like a logarithm in your original expression. Okay, and now let's solve the other one. So this ln of x squared plus 1 equal to 1, and so here I'm going to take the base c exponential function of both sides, which is, remember, is the inverse of the natural logarithm. So here I'm left with x squared plus 1 is equal to e to the 1, which is just e. So here x squared is equal to e minus 1, and then x is equal to positive or negative square root of e minus 1. Okay, and again, I don't need to worry that this number is negative, because when I'm inputting it into the logarithm, x squared plus 1 will still be greater than 0. All right, so there we have, looks like we've got three answers here. We have that x can be equal to 0, or x can be equal to plus or minus square root of e minus 1. All right, so just to do a quick recap here, they're telling us to solve for when the derivative is equal to 0. I chose to put this in quotient form, and again, doing this is what made the simplification process so easy. Okay, and a quick tip about the simplification process, remember, always look for common factors. Okay, that's it for this one.